So up till now we have seen that we need to execute these 3 or 4 steps in an iterative way in order to perform clustering from a data set. And we have seen its algorithm, its flowchart, and we have seen 2 different examples in which we took a numerical data set, and on the basis of their attributes or properties, we basically formed 2 clusters. Now, one important question is that what is the stopping criteria which we should choose in order to terminate our algorithm. So if you remember, when we were discussing our neural networks lecture, you know that we basically had 4 and 5 stopping criterias. We discussed these 5 stopping criterias, and we saw that which are the problem domains or situations or circumstances under which stopping criteria can work better. And we also saw that we can also employ more than one stopping criteria in order to have good performance result. So similarly, in the case of k-means clustering algorithm, we will see that we have some different stopping criteria which can help us in order to have a good performance out of our algorithm. So number one thing which we can do is that we can have a fixed number of iterations. For example, if I terminate with L has been completed. So number one stopping criteria is that we can assign a counter to our iterations, and we can set that this is my maximum number of iterations, and when my algorithm will reach to this maximum iteration point, I will terminate the loop. This condition limits the runtime of the clustering algorithm, but in some cases the quality of the clustering will be poor because of an insufficient number of iterations. So the biggest problem with this terminating criteria is that we don't know that the value which we selected for the maximum number of iterations is optimal or not. Right? For example, if I choose 10, that the maximum number of iterations can be 10 in my algorithm, so I am not sure that after the 10 iterations my algorithm will reach to convergence, right? So if it is far away or beyond from the convergence, then in that case the results of my clustering algorithm will be very poor, and maybe they are that much poor that maybe those results are not even acceptable to me. So this is the biggest problem when you when you have a fixed number of iterations. So in that case your algorithm may result with poor results. Assignment of documents to cluster, for example, that the partitioning function does not change between iterations. So the second criteria is that we will look at the change in the clusters, or we will see that how much is the change in the clusters and after each iteration. So if we don't have much change in the clusters, then we can say that we can stop our algorithm. Except for cases with a bad local minimum, this produces a good clustering, but runtimes may be unacceptably wrong. So if you choose this cluster, this terminating criteria, so in most of the situations this terminating criteria gives good results. But if your algorithm stuck in a local minimum, and you know now that what a local minimum is, you know that I showed you a graph in which we have a local minima and global minima. So if in your problem or in your data set you have a bad local minima problem, then in that case it might be a possibility that this terminating criteria may not work for you. But in most of the cases where we don't have a bad local minima problem, we can have good results with this terminating criteria. But another thing is that it may take a long time if you set this, so it means that the training time will be larger. Centroids do not change between iterations. So this is the third condition which you can check, or third terminating criteria which you can check in order to stop your algorithm. So you know that we are basically changing our centroids or updating our centroids after each assignment, right? So we can see that after each assignment, when we change or update our centroids and there is not bigger change between 2 successive iterations, then we can say that this is the point where we can stop our algorithm. And this is equivalent to gamma not changing. terminate when RSS falls below a threshold, right? So this is another criteria in which we can set a threshold, and we are basically looking for the squared sum. So if the value of RSS falls below to a specific threshold which we have already set, then in that case we can stop our algorithm. This criteria ensures that the clustering is of a desired quality, right? Because why it will be of the desired quality? Because we have we ourselves are being setting the value of the threshold, so that's why we know that now it's below that threshold, so that's why we have the our desired quality. But in practice, we need to combine it with a bound on the number of iterations to guarantee termination. So it is very similar to that terminating criteria which we also discussed with the neural networks, right? So we are basically using a terminating criteria with another terminating criteria. So it is recommended that if we are using this threshold terminating criteria, then it's good to have an outer loop which is basically calculating the total number of iterations, because it can happen that it will take very long to go below threshold value, and maybe that long training time may not be acceptable to us. So in that case, we can have an outer loop which is basically on the counter check, and and we can assign it our maximum limit, for example 100 iterations. And if within 100 iterations our algorithm falls, where the RSS value falls below that threshold, it can terminate at that point. Otherwise, at a maximum 100th iteration, our algorithm will terminate. So in that case, I will say that this is the most optimal terminating criteria, because we have a possibility that the RSS value will fall below a threshold, and in case it doesn't fall, then we might not have to wait for a very long time, and we can stop our algorithm based on the outer loop. Terminate when the decrease in RSS falls below a threshold. So it is a very similar to the previous one, but we have a value of threshold, and we are representing that threshold with theta here. So we can have a small value of theta or a large value of theta. So for small value of theta or threshold, this indicates that we are close to convergence, right? But we need to combine it with a bound on the number of iterations to prevent very long runtime. So if we want to prevent very long runtimes, then the suggestion is that we need to have an outer loop which is basically counting the number of iterations. So these are basically 5 main terminating criteria or conditions which we can set on the basis of dataset and our problem domain, and one of or a couple of these criteria can work very well for our problem. Another problem or the phenomena which we need to understand in a k-means clustering algorithm is that how we basically need to select the value of k, right? How can I know that these will be the most optimal number of clusters for my input data set and or for my problem? Because in the previous two examples, we are basically taking k as a random number, and we are initializing it as a random number with the value of 2. But in most of the problems, we need to have some criteria through which we can select the value of k. And there are 2-3 methods, and out of 3 methods, the ALBO method is the method which is used most frequently in order to determine the value of k. And let's discuss what ALBO method is, which we can use in order to select the value of k.